CPSC2100, and I'm going to finish up problem number 3 on coding problem set 3. And coding problem 3 in this set is to write a program that uses bounds and bisection search to find smallest monthly payment to send to pay off the debt within a year. So we're going to go ahead and start with our variables. Balance is going to be the same as we've used for every other problem. The annual interest rate, 18%. Now we're going to have our newer variables, which is our higher bound, which is the balance times 1 of the whole balances plus the annual rate. And all of that divided by 12 will give you your highest payment to pay off the debt. We're going to set our lower bound to the balance divided by 12, which is the months. So we're going to use a while loop while these conditions are true. I forgot a variable. Got to add total count to keep track of how many iterations we go through. The total count, while this condition is true, is going to go up by 1 each time it's iterated. And if that total count winds up going greater than 12, we stop the loop. Now we're going to create some variables inside of our loops so they don't change our global variables up there. So we can just change them inside this loop. We're going to do new balance equals balance, which is just going to transfer in our new balance. Payment, which is going to be calculated as lower plus the higher divided by 2, which is just an average of those payments. Didn't see that. For each month in the range 13, the new balance is going to subtract and total the payment it's also going to add the interest. Which is the new balance times the annual rate divided by 12, which would be monthly interest. And here we're going to print just to see each round, because it showed me this in the video that was on the assignment page. And I thought this was cool to see, so you can see how it goes over all of these things. We're going to go over our lower bound, our higher bound, our payment, and our remaining balance. And it's going to print this each time it iterates. And I could remove this if I wanted to, but I really like it because it does show you kind of how it works. I'm going to go ahead and round each of these to the second decimal, just to make it a little bit cleaner. easier to look at. Okay. That's just kind of showing you what that did. Like it just went. Went over 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah. So we can see here that our loop runs 12 times. That's the max count that it'll allow. That's the max it'll do. And we also see that it will print each time where these things go to. Okay, so now we're going to add more of our logic to this. If -1 is greater than or equal to the new balance, and if the new balance is less than or equal to 0. So basically, as soon as we get into the negative numbers, that's what this is looking for. Print. We're going to go ahead and print our lowest payment. And it's going to break right there. And that's only if the new balance reaches below 0, but also not too far below 0, because it's only going to go down to -1. So within $1 of being negative. Now we've got our else if statements. New balance is less than equal to. Alright. Our new balance is greater than 1. Lower now equals the payment that was calculated. If the new balance is less than -1, higher is going to be assigned the value of the new payment calculated. Okay. Now let's see what happens when we run this. Okay. Looks like it iterated over it 9 times. As you can see, it's got the values over here, the remaining balance. It went too far in the negative there, so it would have assigned the payment amount to the higher bracket, or to the higher variable. And then on the next one, it looks like the remaining balance was $214.55. And that would mean that this payment right here, $435.42, would have been assigned to the lower variable. And then it's going to go again to $90.46, which is going to change that lower variable to $444.79, down to the balance of $28.41, which is going to assign that lower variable $449.48. And it looks like we dip back into the negatives there, and that's going to assign the $451.82 to the higher boundary. So it's kind of narrowing down as it goes, more and more and more, to get closer to what you're looking for until it finally arrives down here to what we stipulated in our logic here. And it's going to assign the payment 451.68 to the lower variable, but it's also going to print this is the lowest payment, because at this point this becomes true. So it's going to print lowest payment and the payment amount. So rounded to the second decimal place. So there we go.